Good afternoon, everyone. Welcome to our second World Majlis during Health and Wellness Week. Today it's at the speed of life, the future of faster and safer medical innovations. And welcome to everybody who's here at Terra, the Sustainability Pavilion, and to our friends who are watching online. And a big thank you to the USA Pavilion, who is co-curating and co-organizing this World Majlis with us. We have an amazing group of people today, people that devote their lives to saving lives through research, through exploration, and through exploration of safe medical innovation on Earth and in space. And these days, we're certainly witnessing changes that are taking place at the speed of life. We probably, each and every one, feels it on our daily life. We see it on our daily work. And we hope to explore a little bit not only how COVID, which is what is shaping every moment of our existence, but also the other medical innovation that we don't really talk about as much, or we don't yet understand, trying to explore what they are, what are their far-reaching implications, and how all of us can actually start trusting and enjoying the benefit of how our life can be better now and in the future. So I would like to introduce this wonderful group of people, starting to my left, Dr. Yvonne Cagle. She's a physician, she's a professor, and a retired Air Force colonel, and former NASA astronaut. Well, we all want to hear a lot more about what's happening up there. Professor Sergio Brignani from the University of Milan. He's part of the Italian National Committee for COVID. He's a professor of molecular genetics, and he can also tell us more about his area of research. And Dr. Walid Zaher, the Chief Research Officer at our beloved partner, G42, in the G42 healthcare section. To my right, Professor John Fraser from Queensland. He's the director of the Critical Care Research Group and certainly on the front line of emergency medicine. And we'll hear more about your work. Dr. Mehander Nayak, Senior Vice President of Takeda Pharmaceutical. And last but not least, online from Rochester, Minnesota, USA, we have Dr. Anton Decker, the President of the Mayo Clinic, and Professor Raghib Aled, who works between Oxford and Abu Dhabi, leading important projects on genomic and public health. So welcome, everybody, and I guess that we can start, we would like to start trying to explore a little bit what, in this age of exponential technology, where everything is happening faster and more broader, what are the big transformations that you see in the area you work on? And I would like to start with our friends who are online. Dr. Decker, the Mayo Clinic is certainly at the cutting edge of cure, of research or innovation, both in the medicine as well in the delivery and the treatment. Do you want to talk to us a little bit about what are the big changes you're seeing?
Yeah, gladly. Well, firstly, thank you for the introduction, and it's a privilege to be in this forum with such esteemed colleagues and speaking about such a fascinating topic. You know, when we talk about disruptive developments or innovation in healthcare, there's never been a more exciting time to be alive or to be part of the healthcare sector. I think there are three main things that come to mind, really just getting right to the meat of the question. The first is genomics and everything that goes with it. The ability to sequence the genome, what was once seemed impossible, was completed in 2003. And now from that, we can sequence individual genomes, population-based genomes, which allows for targeted medical therapy, gene therapy, and we've only just begun, where diseases that were previously incurable are now suddenly potentially curable. The second disruptive innovation, I would say, is the ability to share data and learn from it. A perfect example would be the development of the COVID-19 vaccine. That was an example of scientists and countries coming together, sharing data, and finding answers in record time. And then the third disruptive innovator, I would say, is the whole world of virtual care, telemedicine, digital health. Suddenly, access to top-level healthcare isn't the privilege of a few, but we are slowly or rapidly moving towards a place where everyone in the world can get access to the required knowledge that they need, or their physicians can get access to the required knowledge, so they too can be treated and cured. It's a fascinating time to be in healthcare, and I would say those are the three big disruptives that we are following most closely.
Thank you, Dr. Decker. And certainly these areas of data and virtual will come back a number of times in a minute. Dr. Raghid, would you like to continue our online Majlis for a moment and pick up both on the genomics, which is part of your research project, and as well as data?
Yes, thank you. So I think one of the things that I've certainly seen over the last 2 years, so I'm slightly unusual in that I work in public health and prevention, but I'm also a frontline physician in emergency medicine. So what I noticed treating COVID patients over the last 2 years is something that I noticed maybe 20 years ago when I first started medicine again, that although COVID is an acute disease, and of course is caused by a virus, those who are worst affected and who are most likely to have severe disease or end up in intensive care or to die were those with chronic diseases like obesity, diabetes, hypertension, etc. And many of those chronic diseases are preventable. Certainly, they can be kind of delayed to older age. I think the biggest challenge we're facing in healthcare is the prevention of these types of what we call chronic diseases or lifestyle diseases that are mainly determined by our lifestyle habits. And what we've learned over the last 2 years, I think, is going to help us. So we've seen that when scientists, when politicians, when doctors come together, we can really make huge advances in a short period of time. And if we give the same attention to these diseases, things like obesity and diabetes are unusual in that they've increased over the last 20 years, whereas most chronic diseases have decreased, particularly in highly developed countries and high-income countries. So we've really struggled to find a way to reverse this increase in obesity and diabetes. And I think through a combination of genetics, so for example, the study that I lead in Abu Dhabi, we're looking at risk factors for these common chronic diseases, trying to understand both lifestyle and other behaviors, but also to link that to people's genetic background and their susceptibility, excuse me, through using polygenic risk scores. So a combination of both of those things, developing interventions through mobile phones, through the internet, online, because we don't have enough doctors, we don't have enough healthcare workers to deliver these interventions. So I think a combination of all of these technologies that have become commonplace over the last 2 years really help us to tackle those huge challenges that we've really struggled with for the last many decades.
Thank you. And Dr. Walid, G42 is very much at the forefront of innovation in healthcare. Do you want to talk to us through a little bit what's in your pipeline and in your R&D areas?
Thank you very much, and welcome to all our esteemed guests here in the Majlis. I'm honored and humbled to be here with such honorary guests. And I guess I just have to capitalize on whatever Prof. Decker and Prof. Ghalib have said, and just in a nutshell, explain Group 42 vision in taking these crucial pillars of how research is going to disrupt healthcare in the future. And this is exactly what Group 42 is trying to do. So Group 42 was in the forefront of the pandemic, fighting the spread of the COVID. We established one of the first diagnostic centers in the region. Then we shifted from there to the vaccine consortium with the world, trying to develop a vaccine with our partners, and we partnered in one of the largest human clinical trials for a COVID vaccine that resulted in one of the WHO approved vaccines. In parallel, while we were in a pandemic, that did not stop Group 42 from starting one of the most ambitious programs in the world, which is the Emirati Genome Project. In that project, this is whatever we think that's going to be so disruptive, not only to the healthcare system in the UAE, but in the region, which is one of the pillars of the future of medicine. How can you take healthcare from being an area or a practice for sick people to be an area or practice for healthy people? And adding to that is our track record as a Group 42 company in data and in artificial intelligence. This is the bread and butter of Group 42. When you add all three together, you end up with a Group 42 Healthcare, which is a company that has only one goal: how to shift traditional healthcare within the region from being just reactive to being preventive, proactive, and personalized. And this is what we are trying to do currently.
And we hope we're going to hear in the course of this World Majlis a little bit more about the
Yes.
Ua Genome Project. And talking about the, however, linking as we're introducing the rest of our friends here, linking to being at the forefront of the pandemic, Professor Fraser, what have you learned in terms of disruptive innovation from being in the front lines of COVID?
I think what I've learned is that, as Churchill said, never waste a crisis. And this has been a terrible time for all of us. We normally, as medics and scientists, come together to communicate, and we couldn't do this for 2 years. And it's wonderful, and thank you, Shukran, to the committee for asking us to be here. It's lovely to get on a plane again. But whilst we couldn't travel, our data still can travel, and our data can make differences. And what we did in our group as intensive care specialists around the world, we in Australia were very protected. We're a very big island, a very long way away. So we had very little disease, but our colleagues across the Asia Pac initially, and then in Milan, started to see this problem with the virus, and we wanted to help, but we couldn't help. We had no experience. So we worked with them, bringing the data together completely de novo, and creating a global family of the intensive care specialists from just, I think it's just under 400 hospitals, and bringing the data together, and then asking the clinicians across the globe, how do you want to share this? How can it help you? And again, working with industry, we have to work with industry. We worked with IBM and the Gates Foundation to create a dashboard where, for nothing, we can give this data, we can democratize the data to assist clinicians in the intensive care, how best to treat them. So I think what I've learned is the power of digital. You know, we feel we would meet every week at 9 p.m. Australia time and 9 a.m. the next day because we covered 54 countries. And it wasn't just a data sharing, it became a safe place. You talked about the mental health before in your introductory film. The mental health of the clinicians in the intensive care, particularly in places like Milan that lost 20% of their intensivists before there was a vaccine, it was really frightening. And no one knew what to do, and there's nowhere you can go after intensive care. Once the patient's in intensive care, the next step is survival or the morgue. So not only did we share data, but we shared stories, we shared laughs, we shared tears, and we created, I guess by mistake, a global family, but that's what we have to do after this pandemic. Carpe diem, seize the day of working together rather than in silos, because that's the way that we can improve outcome, both in acute care, but in chronic disease as well.
And Professor Brignani, I think there's a very interesting kind of balance here between leveraging something that was known and that allowed the speed of innovation versus this incredible unknown of something that caught everybody off guard. Would you like to share the experience of Italy, which was very much in the front line of the pandemics?
Yeah, we're actually the first country out of China to experience the first wave of pandemia. It was very human what happened, because until January 2020, we were all convinced that infectious diseases was a problem of low-income countries. In Italy, every year, 700,000 people die, 70% of cancer, cardiovascular disease, and the rest of all the possible clinical cases. Infection was considered for patients in chemotherapy who were dying of infection that were overlapping. Suddenly we discovered how fragile we are with the new virus, which was never experienced in the Western world before, after World War II, after the antibiotic and the vaccine era was. So we really discovered that, I give you just a number, in Italy in 2020, 10% of people who died of COVID. 70,000 people died of COVID out of 700,000 total death. And normally, before 2020, people dying of infectious diseases were a very minor fraction. Essentially, chronic viruses like hepatitis C induced diseases. So we experienced how fragile we are. We realized that infections can be very dangerous, and we were totally unprepared. We're part of a circle of people working on immunology, vaccinology, and I remember a few years ago, we were talking about our meetings, talking about a pandemic flu, because we were expecting a pandemic flu, not a pandemic coronavirus. And sometimes we met politicians and were addressing, saying, we're not sure only when it will happen, but not if it will happen. It did. So now we learned that it can be. So it was a stress test, a tremendous stress test on the system. And always a stress test, you learn a lot of what is solid and what is very weak. And what we're working now, which is very important, is because a fraction of us is working on how to solve the problem now, and a fraction of us is working in avoiding in the near future that if it arrives a second, whatever, that we're prepared. So the preparedness, it's a word which was absent in the medical world before. Now everybody's talking about the preparedness to the next one. And I think it's very important because with the fragility we showed, it's very important we prepare for this. So we're just working how to avoid in future that if anything arrives similar or different. Also because it's the century of coronaviruses, because no one realized that, or actually a lot of people realize, but we don't rationalize that we had the 3 spillover in 17 years, SARS-1, 2002, and then was MERS in 2012 in Middle East, and then in 2019 was CoV-2. We thought because of the first two, which were quite stupid viruses, because you get infective only when you were symptomatic. So actually it was very easy to contain. With this one, it's like flu. But every 7 years, we had a spillover from bat and intermediate host and the man. So we can reasonably expect, because all the causes that generated this spillover are all there. All the infrastructure, all the countries that are contributing, and the reasons that are contributing to this. So we should expect in the next 10 to 20 years a fourth spillover of coronaviruses. It could be a SARS-1, which would be easy to contain. It could be a SARS-2, which would be a major problem. It could be worse, because it's a virus which, although it's terrible, it has a lethality which is still limited, because 1% of people overall are dying of the infected one. And if you are vaccinated now, it's 1 in 1,000. We'll talk about this. So
we'll come certainly to all of the process and all of the lessons, but certainly picking up on the word fragility and pioneers. Dr. Kegel, you are an astronaut and a doctor, bringing together these two aspects. And before we get into some of the innovations in medical science that come in from space and what you have contributed. Just talk to us about how these two parts of your life, of your expertise have come together and what they have taught us.
Great, thank you. It's wonderful to be here. And I have to tell you, I'd love to have a few moments just to give you a view of the spaces that we work within. Yes, Dr. Yvonne Kegel, astronaut, and although I'm a retired flight surgeon, I'm still very much an aerospace surgeon. And I have to tell you, I think what I do is awesome, but you are amazing because it's been only 8 minutes and 31 seconds, and you're already approximately 250 miles above the Earth, going 17,500 miles per hour on your way to Mach 25. And your body has already endured and surpassed the equivalent of 6, count them, no less than 6, 25K marathons that you've just run back to back. And your DNA is already programming you for the recoding of the oxygen-depleted, radiation-laden, water-deprived, hypothermic darkness of our silent cosmos. And as you unbuckle your seatbelt, you're floating. Within 90 days, your body is already starting to divest the excess muscle mass and bone density that you're now, albeit 2-inch taller self, had the audacity to carry with you off planet as you packed for microgravity, going back to the moon, onto Mars, and whatever else lies beyond. But trust that we are wonderfully and unfathomably made, coded for resiliency, designed for thrivability. So as my good friend Jeff often opines, just how does one begin to access the wisdom of 2 million years of evolution? Well, you are the future of safer, faster medical innovation. Yes, you. And it is resiliency and longevity. And that future is within reach today because the body has an incredible capacity to renew itself. So I look forward to joining with our thought leaders and all of you, because it will take a different way of looking at, of perceiving, thinking about, stepping through novel and accelerated ways to achieve safe and sustainable solutions that can restore not just our bodies, but our environment as well. So I have this opportunity to share with you some innovations that we're looking at, very exciting, very intriguing. And I invite you to join with all of us and me as we sometimes hyper-accelerate to Mach 25 and continue innovating at the speed of life.
Thank you, Dr. Kegel, and I think you just set the seeds of starting to see how do we maybe disruptively think about how we study life, because I think that certainly COVID has already told us how much we know and how little we know, and put us in the face of, so much of the unknown. But before we get there, and we'll get there just after Dr. Mahander, the point of view from the pharmaceutical industry, certainly, a plethora of R&D there, and how much life and understanding of our bodies and ourselves is still escaping us.
Fantastic. Firstly, it's a great honor to be here and being part of the panel on World Majlis. I represent Takeda, which is a global pharmaceutical company which has a 240-year of history. We're very proud of the legacy. And over the last 10 years, we've been reinventing ourselves in terms of where to focus on based on innovation. But the pandemic really shook us, and much like many other pharmaceutical companies across the different ecosystem, we were challenged. But one silver lining that I see is the number of partnerships that have happened within the pharmaceutical industries, traditional competitors coming together, and of course, we are very familiar with one of them, a two-member startup company led by scientists, collaborating with a global pharmaceutical giant, has saved many lives. And what we've seen, I was very interested in seeing some statistics. In the last 2 years, there were around 94 partnerships in support of finding innovative ways to help COVID-19 vaccination research. This compared to the previous 20 years, you had 100. So the speed of collaboration is something that we are seeing now, not just inward, outward, and in terms of innovation, we're really making a lot of headway there.
So talking about collaboration, because our theme is all about connecting minds, creating the future. And when we talk about space as well, we had Space Week was the second week that we hosted here at Expo. And big projects like the Mars mission in the UAE, we could do that in such a short time because of the collaboration that took place from, the US to the Gulf to Korea and Japan and Asia. This is a similar area where we need to greatly accelerate, and collaboration is a big piece of that. I'd like to first of all ask our online friends, so we make sure we don't forget you, as if you were physically here with us, a few comments about collaboration, and then everybody, jump in to talk about how collaboration has really changed how you do things and how you view the programs and that you're developing. Dr. Draker, would you like to start?
Sure, gladly. I would agree with my colleagues and what you said about collaboration. It's never been a better time to collaborate because technology is making it so much more convenient and easier. We're essentially collaborating now. I think, do any of you remember just how clumsy video conferencing was 5 years ago? And now we're sitting here, it's like I'm living in a futuristic movie. We're starting to take these things for granted. But I think the biggest driver of collaboration is the ability to share data. And we saw this with the development of the COVID vaccines. Of course, sharing data comes with a whole new set of concerns, and that's obviously data privacy and that type of thing. Slowly and systematically, that is being addressed globally to the point that the public is becoming comfortable with how their data is being used, and they have every right to know how their data is being used and that it is safe. Mayo Clinic is at the forefront of that. We have something called the Mayo Clinic platform that is led by a colleague of mine, Dr. John Halamka, that does exactly that in an ultra secure environment, brings enormous data sets from Mayo Clinic, which has curated data going back over 100 years, with other data sets, population, industry, and so forth, to start finding answers. So to me, the word collaboration and data go together as long as it's done in a very reliable and secure environment.
Who wants to follow suit on the collaboration topic? Well, G42, you are all very much about also data protection and data development as well.
And we are based in UAE, so we're all about collaboration. And as Dr. Decker have correctly said, the past few years have sped up the way we do collaboration, and then the pandemic have added another layer of that. Collaborations now happen online. You don't have to go somewhere to actually sign an MOU or start the collaboration. In Group 42, we are really proud that we are collaborating with a lot of entities within UAE and outside of UAE. I think we are partners with Mayo Clinic when it comes to our genomics project. We are partners with New York University and Professor Raghib and also when it comes to the genomics project. on our vaccination program. We partnered with a lot of entities within the UAE and outside of UAE and with countries within the region to actually ensure that the For Humanity clinical trial was a success, and 45,000 people who were enrolled. It was a massive feat to conduct such a trial in this region, and a lot of people told us it's nearly impossible, and we made it. And collaboration is the essence of research. Collaboration is the essence of innovation. Collaboration is the only way to be disruptive in the field of research. And we are really proud in Group 42 that our ties, not only within the UAE or within the region, but it's global. We are a global company. We are agnostic towards nationalities or countries. We work with everyone to ensure that there is a fair and safe development of healthcare products or therapeutics that can be out for our people within the UAE and outside.
Dr. Kegel, yeah, space is really all about knowledge collaboration. What can we learn?
Absolutely. I love the word collaboration. Space is all about collaboration. It's why we step off the planet. You're right. It's an incredible view, an awesome ride, but collaboration is a big part of it. We couldn't do it without collaboration. We couldn't return home without working together as a team. And our sustainability off-planet will depend on how well we collaborate together. And that's a very open, inclusive space that allows everyone to be able to share their ideas openly and freely so that we can synergize and really optimize what it's going to take for us to not just survive off-planet, but to thrive. What I also want to highlight is that space is no longer purely a destination. It's actually a thrilling cosmic flotilla thriving with opportunities to gain deeper insights and innovations into how our body works. And the important thing that comes together when we collaborate with Earth is that it's probably the poster child, the greatest kind of a collaboration that you'll see from Earth to space. Because as researchers position and pursue different innovations that are faster and safer, these are things that certainly will augment and enable us in space. But it also drives an opportunity to gain the benefits here on Earth before we even launch, just because you're trying to collaborate with us off-planet. NASA is doing some really exciting collaborations. One of them is with the Genomics project and Epigenetics as well, helping to generate that epigenetic mapping, but also along the lines of genomics, we're trying to build up that database that we can share not just what happens here on Earth, but how our bodies change and adapt and evolve, and are there opportunities to leverage that for the well-being of everyone. Another great collaboration that we see is with Cedar Sinai Regenerative Medicine Department, where we're doing biomanufacturing of stem cells. In space, because there's no gravity, we find that cell lines don't collapse as much, that they can grow much larger. And there's something about space, nothing like it on Earth, that slows down, delays the differentiation of cell lines. And because of that, these cell lines can grow not just larger, but in larger volumes. So we're looking at scaling up batches doing biomanufacturing in space, and maybe that's a way we can really increase cell lines. And if we can do those and we continue to move forward with our own natural 3D printers in these stem cell lines, and we can start to print tissues and organs that have been damaged or from chronic disease or degenerative processes, fix those, we may find that something like organ transplants suddenly are readily available or much more accessible to the world at large if we can do it in batch. So it's important to remember that space isn't necessarily 250 miles above the earth. It's not that far away. Maybe in your backyard. It may be your neighbor. It may be some country that is struggling to develop and sustain itself. And so the things that you do for us in space are things that translate to those who have taken their own kind of expedition just every day in surviving.
And also wanted to ask Professor Fraser, because space has certainly become more inclusive, and there's a bigger space family. And is there a bigger data and research family that comes together as a result of COVID?
I think there is, and the obvious thing is the scientists and the clinicians and the medics. But I think one group we forget about are the patients. Patients are selfless. Every time you ask a patient to be involved in a clinical trial, I can't remember ever having been refused. Getting the data, joining vaccine studies, giving the data to us, these are the patient's data. And patients invariably want to help people in a selfless manner. And we have a responsibility to treat that with great humility that we've been given that opportunity. I think the coming together, I mean, with due deference to my Italian colleague, collaboration is collaborare, to work together. And I think it is not just the clinicians and the scientists, it's the patients. We are the servant of the patients. So we have to understand that we work for them and with them. I think, despite the fact that we couldn't travel, collaborations grew, as you said quite beautifully, from the industrial point of view, but also the scientific point of view. We have a meeting in May of our 54-country consortium, and we're all excited to be there and have a drink together again. And then we actually realized most of us have never met each other. And yet we've grown an incredibly strong bond. You know, as I think it was Sun Tzu said, a clay pot can sit in the sun all day, and at the end of the day, it's still a clay pot. To become a porcelain vase, you must first go through the heat of the furnace. And I think the frontline clinicians and the immunologists and the scientists, they have been through that furnace. And inshallah, what will come out at the end of it is a porcelain vase of better science, more inclusive science, better medicine and integration within an industry.
So how about you tell us what that furnace looks like? Because it will seem to be very high temperature, but also quite quick, right? And I'm referring to the speed of innovation to get to the vaccine that get everybody really scared. So how about you help us understand that process?
I think COVID has been a great, a tragedy, but was something which showed how powerful mankind can be under stress, because developing vaccines in 8 months could be possible because public sector, private industries, researchers, clinicians, everything was focusing on getting to the point where vaccines should have been developed in the shortest time possible. And it was done. It was done respecting safety issues, respecting everything. It was done because, essentially for 2 reasons, because unlimited resources, which were not a few dozen billion euros were put in the game, which it's a lot of money, but it's nothing compared with the cost of the pandemic. And they neutralize completely the risk that is in every stage you have, because a vaccine is developed starting from preclinical talks, phase 1, phase 2, phase 3, registration, production, marketing, and everything was done step by step, because each step has a risk of losing money if it doesn't work. So, but if you know that you can do, rather than in sequence, you can do in parallel, and actually it was the way it was done, and everything was done rather than in 8 years, in 8 months. So, and this was something incredibly powerful. It showed how in emergency we can get very collaborative. Ideally, we should be collaborative always, but it's impossible because there is economical interest in. But in this case, COVID should be really quoted as the trigger for the best example in mankind of collaborative work. Everything was done in the most effective, most powerful, quickest way that could be done. I tell you, having vaccines in 8 months, I just give you another data, till 2020, the whole production of vaccine in the world were 5 billion doses for 20 vaccines, which were selling all over the world in all countries. between summer 2020 and summer 2020, actually in May 2021, the production was 11 billion doses of vaccine, of which 6 billion doses were of COVID vaccines. Now, in 10 months, doubling the capacity of producing biological vaccine is something which was incredibly powerful. It was done again because of an incredible effort by everybody. So we should study this case as an example where you could shorten, how you could improve collaboration, knowing that it will be impossible to mimic again in a normal situation, but we know how to do it now. And we know what are the steps that can be accelerated, improved, and obviously, I agree with you, collaboration should be ideal at all stages, but we know that it doesn't work like this because we're human. But if we're scared, and very scared of something, as we were with COVID, actually we learn we can do things very effectively in collaboration.
I think it's true, and without being too inflammatory, though I am Scottish, the medics and the scientists have been seamless working together. Unfortunately, what is risk to a medic and a scientist looking down an intensive care that's full of patients, and what is risk to perhaps some of the administrators are different beasts. We see risk differently. We have gathered 40 million data points of all the ICU patients across the world. But I think, as we've heard, the collaboration has always been there, but there are things that go slowly. Things must be done properly, effectively, ethically, and they have been every single step of the vaccine. But what has happened is we've sped up the other things where you say to people, this piece of paper is waiting for sign-off for 6 weeks. That can't be acceptable. If that is delaying things, that must be made better. And I hope this is one of the good things that comes from the pandemic, that the other aspect that can delay research, it must be done well, it must be done effectively, it must be done safely. But there are places that it gets slowed down, and hopefully we can get that better too, because it's better treatments, better understanding, and better teamwork.
I would like to know if both Dr. Ragid and Dr. Decker, would you like to respond to these 2 points?
Yeah, I'd come back just to make a couple of comments. I mean, I think the vaccine, of course, has been a great success. And for COVID, where a pharmaceutical intervention was really critical to reducing both hospitalization and death rates, it's been a great success. But as I mentioned at the beginning, the key health challenges we're facing in the future are really not as amenable to pharmaceutical intervention, whether it's unhealthy diet, physical activity, use of tobacco, alcohol, mental health disorders. These are the primary causes of poor health throughout the world today. And what we really need to see is really going beyond just the traditional kind of areas for finding these cures. Of course, pharmaceuticals is extremely important, and it's made a huge difference to many chronic diseases as well. But it's in that area of prevention where I think we're really struggling. And I hope that this spirit of collaboration we've seen, and it's been very important for my own study here as well, between public, private sector, governments, universities, hospitals, and international collaboration will continue. But as I said, to tackle these kinds of challenges, which are much more difficult actually to solve, because it relies on changing people's behavior, it relies on changing government policies, and it relies on things which, as I said, are somewhat outside of the traditional areas of both how doctors and scientists have dealt with disease.
Just to connect this point, Dr. Decker, also from where you stand for the Mayo Clinic, I'd love you to comment on this part, but also building up what Ragib has said, that there are other things. Have we, at the time of COVID, as we have put so many efforts that have accelerated the vaccine and addressing this, have we neglected some other people, some other treatment, some people that didn't have places in the hospital? And have we been good or bad at multitasking or not?
Well, there's a lot to unpack there, but perhaps as we shift slightly, I'll build on what Dr. Ali was getting at, is the whole world of preventative medicine and what we're going to do about dramatic rise in non-communicable diseases. So really due to the brilliance of modern medicine, so many communicable diseases, infectious diseases before COVID really dramatically improved. Antibiotics, vaccines have allowed people, families to live beyond childhood and into old ages. With that, we've had also and I realize there are parts of the world that are very much still struggling with communicable diseases, and that they should not be ignored. And everything we're talking about today is making it possible to address those as well. But on a global level, we have a rapidly rising middle class that now has disposable income to have access to lives of relative luxury, exposing them to new threats. So obesity, because of our predominantly our diet and sedentary lifestyle, and a population that's getting older because they are surviving beyond infancy because of modern treatment, is now more prone to getting cancer, coronary artery disease, diabetes, everything that Dr. Ali said. So we have a whole new problem on our hands. And not everyone likes it when I say this, but we're really victims of our success, right? We now have people living into their 80s, 90s, and beyond in relatively good health, but then eventually the diseases of a growing middle class and lifestyle diseases start becoming a big problem. And they very much have become a big problem globally. So how do we address those? And those are expensive to treat, and they are becoming ubiquitous. And that's where we get back to the fascinating world of data and science, how we collaborate to start finding cures for these things too. Mayo is trying very hard to be at the forefront of that. If we just look at the world of coronary artery disease, cardiology, and I'm going to bring this back to data again, through a EKG project, so that's where you, for non-medical people, those are the little electrodes you put on someone's chest to look at the heart rhythm. We've looked at data, or our cardiologists have looked at data from thousands and thousands of patients, and now can predict certain things, such as heart failure, long before it even clinically happens. So just think about that a bit. The future has already arrived, and that's using modern science, technology, digital data to start addressing some of the biggest challenges of the day, which are non-communicable diseases.
So from a point of view of a pharmaceutical company where, we buy your medicines because we are trying to treat something, are you moving into prevention? What is your focus, in fact? Is still on the treatment or on the prevention?
It's a great question and fascinating insights. So firstly, I would like to say that there's a couple of things which are picked up from Dr. Fraser as well as Dr. Decker, where you're looking at data, right? And when we look at the pharmaceutical industry, we have a lot of data, but are we utilizing it in the right manner that can end up in saving patient lives or improving patient lives? Again, I'm going back to the collaboration where data can be pulled in between different pharmaceutical companies because we have data scattered around everywhere, and can we have a conscious effort to improve diagnosis, improve treatment, and be better at prevention. That's something that I see a lot of effort being put. I guess this is a learning from the pandemic, and it's important for us to learn and also change the way we operate. I'm quite positive about it. I see many companies coming together, as well as with different stakeholders, public health authorities, and patient groups. It's very important that we get this data together. And the component that we've been seeing that has accelerated significantly is a digital transformation. but that's coexisting with the data. Digital transformation can't happen if there is no collaborative data aggregation.
Before I ask also my next question, I would like to make sure that if somebody has in the audience has a question, and some of our colleagues have mics, I'd like to. I'll ask my next question, but give me a sign that that you would like to raise a point or ask. Quick question back on the vaccine and on all of this knowledge, because we talk about innovation that happens at the speed of life, but things don't happen overnight. And I think part of the fear that we have of the new science and the new treatment is that they're becoming more complicated, we don't understand them enough, and there's a general fear of new technologies like, the first industrial revolution, people were fearing the machines that were running across the countrysides. How much did we know? How much do we know already about life? I want to ask Dr. Abrignani about the vaccine, but also what are we learning through the genomics projects that are shedding more light into the mysteries of our lives?
I mean, first of all, let me say that we're lucky that COV2 arrived in 2020 because we had 20 years of research on RNA vaccines that was done in cancer area and HIV area, adenoviral vectors and RNA vaccines were used without big success, I should admit, in these difficult diseases, but everything was ready. So the technology was there. It was a matter of taking it and using it. And this was, the genomic is, and whatever is omics, because not only genomic is epigenomics, metabolomics, proteomics, whatever you add the name, omics is a huge big data interrogation that you can have. You can have even lipidomic if you want. It's all the lipids of your body you can study if you are, okay, if you have enough money. The point is aiming at a stratification. It is stratification medicine. The final aim that I think omics is about stratifying people in a way that they are diagnosed and cured in a better way. You need a precision diagnostic, precision therapy, precision follow-up. But this can be
precision?
Precision is stratifying people in a precise manner. So far, I mean, the classical example is given, so far, most of the drugs we're using are given to everybody, and they work in 40% of patients who are happy. And this should tell us also how effective are vaccines. So remember, vaccines are 95% effective in preventing severe COVID disease, 95, 98. And the best drugs we have, with the exception of antiviral drugs in hepatitis C, usually have 50% efficacy at best. Because we're not stratifying patients, but if you stratify patients, and we're learning this in oncology, it means you stratify because you know precisely what molecule is affecting the type of cancer. Oncology is at the forefront in terms of precision medicine. And precision is just qualifying the identity of the disease in a way that you know what molecule you should target. And this is the aim of precision medicine, which is stratification medicine. In vaccines, we are in an easier world because it's a preventing arena. And we know that more or less we're responding all at the same time. Our immune system is responding to foreigners, as a vaccine is, because it's mimicking a virus, so it's a foreigner. We're more or less responding all at the same way. So in the prevention arena of vaccine, genomics is less important. It will be very important, and it is very important, in understanding adverse effects, adverse events, in preventing adverse events.
Dr. Walid, and then I know you want to add something. So maybe it's also a good time for you to tell us a little bit about the Ua Genome Project.
When we talk about genomics, we tend to explain it as something that is new. And then we come with personalized medicine and say we're going into the future. But if you think about it, it's the next evolution of medicine. It just was gated by the fact that the whole DNA sequencing came late after hundreds of years of medicine innovation. The first antibiotic is more than 100 years ago. Penicillin, X-rays, 50 years ago. It took us maybe 100 years from the 19th century to came up with the first DNA sequence in the late 1990s. And then from there, it took another 10, maybe 12 years for the price of doing that to come down from almost $1 billion for the first one to $1,000, which is it now, which is enabling whatever we can do with it, which is personalizing medicine. Why? Why do we say personalized medicine? Everything else in our lives is personalized. You choose your own car. If I want to buy an apartment, I go and personalize the way I want. If tea is personalized, red tea, green tea, herbal tea, food, how do you want your steak? Rare, medium well? But medicine, while it's the most important thing that should be personalized because I'm different. A car drives me from point A, point B, no matter what is the brand. Might be faster, might be safer, but it does the same job. A drug is different. What we have now is one bill to fit them all. While we are all are very different. I'm not a single person here is identical to anyone else. It's only identical twins that are identical in a way, not fully identical. When it comes to medicine, having personalized medicine is disruptive to everything. Think of cancer. When you produce a cancer therapy, you do not think that while it did pass the clinical trial, and it is safe in most people, and it works in most people, what about the unlucky that are not responsive to this cancer therapy? And these are the people we are trying to target by personalized medicine. This is a medicine that works for me and not works for the mass. Technologies are advancing very fast now. 5-10 years ago, when mass genomics project, maybe led by the Ua Genome Project and then other projects, they started with the short sequencing. Now we have new technologies, the long sequencing, which adds more data, and all of that is supplemented by the huge amount of data that is generated from the sequencing and the availability of high-performance computing and artificial intelligence. All this ecosystem is, I reckon that within the next 10 years, is gonna open the gates of having one bill that fits me, but not everyone else. And this is what we are trying to do with the localized United Arab Emirates Genomics project, which most of it is done at the Omics Center at Group 42 Healthcare.
Dr. Kegel, I see you want to come in here.
Well, the Omics project is very exciting, and personalized medicine really is that faster, safer innovation for our future. And I see two pathways that stem from it. One is equitable, and the other is the environment. Equitable, I say, because now it no longer, medical health and wellness is no longer going to be driven by the masses, that you can be your own universe, and we can find ways to personalize, customize, tailor, design healthcare medicines that will be responsive for you. And that's a wonderful opportunity to bring equity and access to a global planet. The other thing is the environment. When we learn about omics, we're finding out as we map that there are bridges and links to our environment. So there are certain environmental exposures, waste, toxins that can influence some of the chronic diseases that we're seeing. If we can identify those relationships and links, we may be able to intervene in them as well.
Anybody wants to?
Yeah, so I think you mentioned the word equity, and it would be remiss to say that on this World Majlis Day, we've not got anyone from low middle income countries. So the science we've done is fantastic, but the distribution and the equity to vaccine, we should hang our heads in shame. I know that's that's a bit of a downer. But I did a talk in September, and at that stage, in rich countries, call them what you want, 100 vaccine doses had been given per 100 people. In Central Africa, it was 1.5 doses per 100 people. So, firstly, that's wrong. Secondly, it's really bad science. If you don't protect the world at the same time, you produce a variant factory, because the variants just change and change and change, and they will come back and bite us. There was a paper, I think, published, I think the Wellcome Trust was involved in it, and it was just published the other day, saying that the richer countries should be giving at least half of their doses to the less well-off countries, because it's the right thing to do, and we are celebrating World Majlis, but also that will protect us. So personalised medicine is fine when you've got access to free water, clean water and education. Moving that aside, I think whilst that is difficult, what we can do is give these data to the different places across the world, the rich and the poor. Data is free to transfer. And if we can give the global data where they might not have the same intensive care capabilities that we might be used to, or even the same vaccine equity that we've been fortunate enough, we can give this data across. And our data that we have has got City Centre New York, Columbia Presbyterian, it's got Rwanda, it's got Zimbabwe, and the similarities are much greater than the differences in terms of how clinicians work at it.
Is data enough?
Data's not enough. No, data's absolutely not enough, but it's a first stage, and the fact that people, the clinicians and the scientists want to come together and do this, and this is a call out to the governments, to say, no matter how brilliant the vaccine technology is, and great credit to them, and how well the pharma companies are doing, and how well the doctors are doing, and the nurses and the allied health, we have to ensure that equity occurs. We can do it. It's expensive, but it's not just fair. It will diminish the problem of the pandemic.
Is there a question from anybody? Otherwise, I'm going to ask my next question, unless Dr. Raghi or Dr. Decker want to step in into this topic.
I just wanted to mention one other aspect of using genomics, which is linked to precision medicine, but we would describe it as precision public health or precision prevention as well. Because what genomics allows us to do is to understand why people, although they're exposed to the same risk factors, not everyone develops the same disease. So we've known for a long time, for example, that only 10% or 10% of smokers develop lung cancer, 90% don't. And we haven't known before why that might be the case. It's similar for diabetes, obesity, heart disease, and many cancers, that they're exposed to the same risk factors, but they don't all develop that disease. And what genomics will allow us to do, and we already have evidence for this, is to show which individuals are most at risk of developing these diseases in the future. Epigenetics, which is how genes are expressed, is also relevant here. And to take the example of the UAE, we know that despite similar levels, for example, physical activity or unhealthy diet, we have much higher rates of diabetes than the USA, for example. This may be linked to genetics. It may be that we have different kind of mutations in our genes compared to other countries, or maybe due to epigenetics, the way that our genes are expressed here. And the research that we're doing will help us to understand what really is driving those differences in outcomes. And using that information, we can then ensure that our interventions are targeted at the right part of the population and individuals within the population to prevent those diseases as well.
I'd like to throw in a footnote for space. When you're in space, there's a 20-minute delay in communications. So if we're being reactive in medical conditions or crises that occur, we're already a giant leap behind. So our solution is to be as proactive as possible, is to get as far ahead of contingencies or issues before they arise, and we're trying to fight in that reactive place where we're always 20 minutes trying to manage communications from Earth to space. And one of the areas that allows us to leverage to get ahead is to create signatures of each of the crew members that looks like what their omics, their epigenetics, their genomes, their...
Can you tell us what epigenetics is?
Oh,
so for some of those like me who don't.
Right, right. You can probably explain it more, but epigenetics are these chemical caps that are placed on our stem cells. And they influence what our cell lines, our stem cells, ultimately express genetically in terms of our tissue organ functions, what kind of role those tissues or organs will play. And those chemical caps, they can be methylation, phosphorylation, they throw these switches. And if they switch on for bad, some kind of flawed expression, then we can start to see that disease condition start to manifest itself. But on the other hand, you know, if you can switch on bad, you can also switch it off. And that's what we're trying to learn, building a whole mapping system to look at these associations within our own bodies, as well as those links or bridges to the environment. And to do a shout out to self-renewal, if things can be switched off, things good can be switched on. And so the more that we learn, we might find that there are ways, again, that we can influence the role that those caps play in order to help renew ourselves as well.
And you will tell us about your innovation. Do you want to tell us now?
If this is a good time, sure.
Why not?
Wow. Well, first of all, let's take a jaunt in space. I guess I can start and just show you a picture. You may not be able to see it very well, but for those of you who can, I'll describe it. It's a before and after foot of the same triathlete. And this is a gentleman, a triathlete, who was training for triathlon 3 weeks. It was in 3 weeks. 2 days prior, after training for years, 2 days prior, he twisted his ankle and developed what we call a grade 3-4 ankle sprain, soft tissue, very severe, no break on the x-ray. And if you can see, that ankle is very discolored, it's darkened, swollen, painful, can't bear weight, has 10 out of 10 pain, has been taping it for a couple of days, and you know, it's just not working for him. Can't run, can't train, can't even climb stairs. He sleeps upstairs, but he's been living downstairs. So the after picture is after a special precision wrappable technology that I've been looking into at length. And now you see that the foot actually looks very much like the other one, same coloration, minimal swelling is evident, there's no pain, fully weight bearing, able to run stairs, 2 days later was running, 3 weeks later made his race. Now, a grade 3 ankle sprain takes a minimum of 10 to 12 weeks to rehabilitate, to retrain. In this case, it wasn't 10 weeks. It wasn't nearly 3 months. It wasn't even 10 days, not 10 hours, but a single 10-minute session. And why is this important? Well, for those of you who have done competitive sports or recreational and have ever sustained that, or just in your daily lives, you know how this can be disruptive. But think about someone who has a disability, or the aging population, or a first responder trying to rescue. There's so many applications here on Earth. Think of someone in a developing country where they're the working wounded. They have to go to work, and they're limited because of that pain or that swelling. This is soft tissue, not just release, but it's activation. And if that doesn't quite get you going, this is you on Mars. Now, when you're in space, gravity is reduced, so we really don't need our legs as much. That means it's an upper body world, your upper limbs, your arms. Now imagine if you're floating around and one of your arms gets hung up on one of the handrails. There's no gravity to stop you. You can't just stop and remove it. You're going to continue to move until you find some way to brace yourself. By then, you could have wrenched the soft tissue. We're not talking about break structural, but wrenched. You're already deconditioned. In as little as 6 days, an injured limb could have serious risk of being able to rehabilitate. Now, me, I want to go to Mars. I want to stay. I will do house calls on Mars. You may not want a Mars zip code. So it's important to have something that can rapidly rehabilitate you. And 10 minutes means that there's a pretty good chance that you're coming home, possibly even joining in that triathlon race. So how does that happen? What are you going to do when that occurs? you need something that's packageable in space. It may sound like something that can work that quickly is the size and power of a rocket ship or requires the agility of a robot. But actually, I have to be quite honest with you. There's not a whole lot of space in space, and I've actually been wearing it the entire time that we've been talking here. And so if you want to know more about it, please feel free, see me afterwards, and we can talk.
That's the beauty of the World
But-
Expo. You see innovations never seen before.
That's right. But you know, the thing about space is, you know, this is made of things that you can just pretty much take off of clothing or the vehicle itself. And that's important because you can't just come back home. So something that can take weeks of retraining into days and days of pain, discomfort, and stiffness into minutes can really make the difference in a huge way. No matter if it's days or decades old, no matter if you're floating in space or here on Earth, and you just have to make that date.
This almost feels like magic, almost like some of the vaccines. And this leads me to the next question of trusting science and trusting the processes and trusting the medics. But I think it also relates to your comment about accessibility. And it has two faces. One is, do we trust the intent? Because a lot is, you know, is it the big question of this World Majlis or of all of the World Majlis during Health and Wellness Week is, what if the health of others was our number one priority? So part of the trust is, you know, do we trust that there's a profit reason or do we trust that there's a genuine reason? What are the obstacles to get people to understand the intent to make these innovations, whether it's a vaccine or whether it's other aspects of quality of life, more accessible? Who wants to pick up this notion of trust, profit, and accessibility?
I could probably make a reference to a recent public opinion survey that was led by Wellcome Trust Group from London. They did a survey across 113 countries and involved 119,000 people. And this was between August of 2020 and February of 2021, just before the vaccine was rolled out globally. It was very interesting to see from the survey result that public trust in science has increased significantly. It's around 80%. And public trust in scientists is close to that same number. And what the survey also shows, a significant group of people who had not much of a background understanding of science are now more engaged and involved in science. But this is great in terms of looking at the public trust, and I think the industry deserves that, but we can't rest on our laurels. I think one of the things that we realized is also the communication in terms of communication through scientists versus communication through alternate sources, which may not be that credible. It's about building trust, and us as in industry as well as scientists should be out there talking about the science so that people really understand it. And probably from the pharmaceutical industry standpoint, I think you also mentioned that, is to really understand the patient needs, putting the patient in the front and really getting to meet the needs of the patient. So you're doing, whatever you're doing is eventually going to benefit. So that would then build trust as well.
Look, it's a fascinating area. 20 years ago, there was no Twitter, there was no Facebook, there was no social media. We'd do video calls and we'd try and bing, bong, bing, bing, bong, bing, and it was terrible. The access to data has just exploded, and most of the time is wonderful. Being able to disseminate literature, you know, studies like the recovery study showing that steroids are really cheap treatment that can be used in Central Africa. $5 reduces the mortality by 30%. That came out in the day that it happened, and it was phenomenal. So to democratize data and allow people to have access is essential. But what it also means is you can have someone who is an influencer, who may not have passed grade 10 at school, who will have a bigger social media platform to say vaccines don't work. This was a sham. Now, this will always exist, but I think what we as clinicians and scientists, we tend to stick to our methods of disseminating the findings and journals and meetings with eminent people like this. That's great, but we are roughly all speaking the same gospel or hadith. We probably have a responsibility to get into that other lane of people of disinformation of data and oppose it, because this is where deaths are happening. We have the data, we know it works, we know it was done very well. These are people that are being taken down a rabbit hole of mistruths. And we need to be there not to criticize, but to correct and say, actually, that's incorrect. But if we just ignore them and stick in our own lane, then we fail them, and that's our responsibility, that we have to somehow get hip with the lingo. It wouldn't be me that does it, but it'll get hip with the lingo and get out there and disseminate the data in the forums where people are getting misled.
And what about the media as well? Because during COVID, certainly some countries, like our common countries, we would hear everything and the opposite of everything from trusted sources. Mm-hmm. So when you're sitting there, how do you know?
We experience what has been, a new word has been created, infodemia, information pandemia, because it's a situation, it's not an easy word to say, of over-democracy. We're experiencing an excess of access to information, because until a few years ago, the information were limited to our circle of professional. We're filtering, we're somehow working on it. Now, with I don't know whether you're familiar with the bioarchive systems, everyone can post a paper which is not reviewed, because science is based on peer reviewing, experts in field review, and then the communication is spread because it's certified by experts. With the bioarchive system, you can publish before peer reviewing everything. And if the access to this information as it is now is to everybody, not in our field, what you have is an infodemia, because everything is unfiltered and is disseminated as a fact, whereas quite often it's not. You were quoting, John, you were quoting a great example, the steroids, introduction of steroids in therapy, intensive care unit, or in treating patients with complication in COVID. But there are other thousands of examples of wrong information which has been spread and is disseminated, untrust in vaccines, untrust in drugs, untrust in... So obviously, we should deal with it, because now you don't go back. So, and now we should be able to somehow take the best out of this over-democracy and this infodemia. It's not an easy task, but we're here, so it's...
I think a big part of trust has to be information is knowledge, information is power. And we have an advantage as scientists and clinicians that we get to scrutinize the data and the quality of it. We get to look at the scientific rigor. But we can't underestimate the intelligence of the public, whether they are of our same discipline or not. And I think transparency is very important in not just making the data available, but in helping to show and bring transparency to the scientific rigor that we are privy to, so that everyone can make an informed decision.
Dr. Walid?
Well, I do agree with everything that is said here, but I'll play the devil's advocate. So, while yes, there is a negative effect of media on the trust issues, but there is also a positive effect if you look at it from another way. We knew about COVID through media. There was no publications. There was no scientific reports. It took weeks for anyone to have any scientific publication out of it. We knew through YouTube videos of people, whatever, that there is something that is happening somewhere, and there is something that is spreading. And by the time that we got the the sequence of the virus, which for other institutions or other countries to work on to get the vaccine and everything, maybe by that time there was scientific evidence that is published that can support the trust of the physicians and the public. But media played a vital role in educating people ahead and maybe slowing it wasn't a pandemic, it was an endemic at that time. Also media, while it was played negatively against the vaccines, as Dr. Sergio said, but it was also played positively as efforts by Dr. Sergio and other people to actually educate people about, no, these vaccines are safe, these vaccines are just a continuation of science that started before. So media is like any other thing. It's a double-faced thing. You can use it to better the healthcare. You can use it to actually misguide people. So yeah, we have to deal with it as it is.
Before the last question, Dr. Decker and Dr. Ragged, do you have anything you want to add to this communication and information conversation, which reminds very much of, sometimes also trust the science, and we have it happening in climate change, and we clearly have it happening here in these areas of health very often.
Perhaps I'll just comment, and I really appreciate the comments made by my colleagues, and also the most recent comment made about the positive sides of the media, right? That's easy to forget, and I think that's a really, really good point. But I'm just going to bring it down to a very human level. And a reminder of the privilege we have to be part of the science and the art of medicine. I was seeing a patient 2 weeks ago with an unfortunate diagnosis. And as I was trying to give her options, she said to me, or he said to me, "Doctor, I trust you." And that really made me pause and made me feel humble of the responsibility that sits with me. And that brings me just to, as we talk about the excitement of data sharing and the speed of light, or life as you call it, that things are going to advance, that we don't forget the very human level and the relationship between the provider, be that a doctor, a nurse, and the patient, because that's a very special relationship. All my patient wanted to know is that I had his or her best interest at heart. So let's not forget the human level, the one-on-one relationship between patients and their providers.
So this World Majlis is running through literally at the speed of life. And before we close with a short video, I would like to take a comment from everybody, starting with Dr. Ragged. What is the future of healthcare as you see? I mean, we've spoken about data, inclusion, about greater understanding, collaboration. We talked about acute and chronic. 30 seconds, what can we look forward to, and what are the big challenges we need to continue to work to overcome?
Thank you. I mean, I just wanted to comment briefly on the last topic as well, because I think trust is going to be critical to realizing the potential of these new technologies as well. So whether it's genomics, whether it's the use of AI, whether it's the use of new therapeutics, what we have learned through the course of the pandemic, and I've been heavily involved in the rollout of the vaccine in the UK, is that if people don't trust you, whether you're a doctor or a scientist, people will not take the vaccine. And that's actually been one of the reasons for low take-up in countries, particularly in Africa. And it's not just a supply issue. There has to be trust there as well, and in minority populations in Western countries as well. So people also have lots of questions and concerns about genetics, about the use of artificial intelligence, which in the future will often replace healthcare workers. And so I think we need to work with the public at large and our patients, take them with us on this journey to make sure that they trust these new technologies and that they will benefit them in the future.
Dr. Mahandi?
Yeah, I look at pharmaceutical companies probably have an obligation to discover as well as deliver life-transforming medicines. And with a strong commitment to patients, people, and planet. We didn't discuss much about planet, but I think there's a strong emphasis on that. But also leveraging data and digital as we move into the next probably 10, 20 years.
Yep, I think it's probably the right area of the world to say that data is the new oil. Data will empower us, data will get us further. I think we can congratulate the scientific, particularly the vaccine community, of how we've done so well with COVID, at least in rich countries, but we need to look at doing better with poor countries. So our children may give us an A+ for what we've done with COVID, but I think the major problem we've got is climate change. And in 20 years' time, when our kids ask us what do we do at the time, we can tell us what we did with COVID, but they might give us an F- on ignoring climate change, because I think that is probably ahead, particularly in low-middle income countries. That will be one of the biggest crises of our times.
I'll take away your link between our body and the rest of the environment and the commonality of the DNA, that maybe that is also, you know, something that gets us more in this connection between how climate affects our health. But your view of the future?
My view of the future, just like the wrappable technology activates soft tissue, there's no engine, there's no sensor, it's the power of you. And that's the future. You know, learn the language of the body, and let's find ways that we can self-renew. And in space, we don't have the luxury of being able to do things invasively. We have to use ultrasounds. We have to use ways of imaging that don't allow us to cut and do surgery. And that's where some of the exciting innovations are going to come through, is they're fast and they're safe. And so there are sensors out there now that we're looking at where you don't have to do brain surgery in order to see the pressure in the brain, that you can use a very comfortable headband, and instead of an hour under anesthesia, in a few moments, you can actually find fairly reliably what those pressures are in the brain. We have other innovations that help us with our sleep, because sleep is the most powerful medicine in our body that we can leverage. In deep sleep, it appears that's where we get our lymphatic clearance, where we can clear out the waste and toxins from within our body and in our environment. So sleep is so important, not just the number of hours, but the quality of sleep. And studies are going on to see if there are ways that we can sleep while we're awake that can help the transportation industry, truck drivers, airliners, astronauts, elderly who have Parkinson's or Alzheimer's, to improve their cognitive behavior and mental wellness. And there are other innovations that we are looking at where if for some reason your body has gotten away from you, either through some kind of oxidative stress from shock, either you've lost a lot of blood through trauma, or you're dehydrated, or you have an infection that has riddled your body and now you're in septic shock, there are garments that you can place on your legs and just serially wrap up the panels up to your abdomen. They're non-inflatable. You can take them in airplanes anywhere, and it can give your body a break from having to support your blood pressure until either you can recover or doctors can find out what medications or interventions will help. So there are many non-invasive wearable things that are leveraging the power of you and ways that we can sense it even before you have symptoms of low oxygen, for example, or symptoms that are reflective of an oxidative stress. Too much oxygen, hyperoxia, can be as bad as too little oxygen. But if you can detect those things early, before you even have symptoms, you don't have to worry about, you know, any kind of delay that is going to affect your survivability. And in space, you don't have to sit there counting the clock on 20 minutes. So think about that. The power of you is available right here, no matter where you are on the planet or in space. And you have access to it. So let's learn how to activate it.
You called us natural 3D printers
as
well, before Dr. Abrignani.
Yeah, having spent most of my life in vaccines, infectious diseases and things, what is important is where is prevention. Prevention. In the future of medicine, you cannot have therapy for 10 or 20 billion people. It's impossible. What you can have is a prevention which will be based most likely on a very accessible stratification of individuals based on what is their risk of developing whatever will be for each of us a risk of any disease. So prevention is the key word. And to the climate, we should move also on to prevention now very quickly, because the therapy will be impossible, very complicated. And so prevention really is the key word for everything. And there is a lot of wisdom in this word. You should prevent whatever can happen that is unfortunate, this climate disaster. So we should intervene really with prevention.
Dr. Walid.
I think the future of medicine is data. The future of everything now is data, as John correctly said. Everything that we have discussed here is being translated into data, and not data that we used to have 50 years ago. It's big data. Whoever is going to invest in analysis, in AI, in finding ways to leverage this data to understand and act upon how to disrupt the healthcare and the future medicine. This is where the future is going. Data in everything, but data in medicine is whatever is going to be very disruptive.
And Dr. Decker, we started with you in Minnesota. We're going to give you the last few words.
What a privilege, thank you. Look, briefly, I don't think there's any stopping the advancement of medicine. It's going to move faster than ever before, and it has never been more exciting to be part of this. There's now a vaccine or vaccine trials for malaria. Many cancers are becoming chronic diseases. Things that I used to send people home to die when I was in my training now have targeted therapies. It's all happening as we speak, and it's going to move at the speed of light. My one closing thought is that we don't forget the human aspect at the end of all of this, and that we continue to treat patients as a whole and their families, and remember to pay attention to their psychological and overall well-being as healthcare moves at the speed of light.
Wonderful.
Thank you so much. Thank you, everybody. Thank you to all of you. Before we close, courtesy of Dr. Fraser, we have a short video to share.
Pintura, Purlama. Colaboração, trabalho em equipe, comprometimento.
Umoja, upendo na uhai.
Science, passion, leadership.
I wanted to say thank you to the COVID Critical Care Consortium for giving us hope, collaboration, research, data on best practice, and thank you, Australia and Queensland, for supporting this effort.
Gracias, Queensland.
Thanks to Queensland.
Shukran, Queensland.
Thank you, 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 Queensland.
Thank you again, everybody, and wishing everyone a wonderful evening here at Expo 2020.